So we're out here today showing some techniques to sample soil. The simplest technique is to use a shovel you have for like your garden. The downside to this is it's harder to measure specific depths, but on this spade, for example, we marked where 4 inches down is. So if I want to take a sample that goes to 4 inches down, I can put the shovel in the ground to the line where it says 4 inches, and then I can scoop it up and grab this, and now I have soil that goes down to 4 inches. And here is the soil we pulled up. And then you can take this and homogenize it and take a subsample of it, or just place the sample in a bag to do your desired field test. Another method to sample with is a push probe. Stand on the push probe, and you want to keep it as straight as possible. Oh, there's the other push probe. And then you want to pull it up very gently so the soil core doesn't fall out, especially when the soil's dry like it is today. And then you get a nice round sample like this, and if you want to get it from precise depths like 0 to 4 inches, you can take something that's labeled and you can cut the samples at 4 inches and cut the samples at 8 inches, for example. So here's 2 soil chunks cut at 0 to 4 and 4 to 8 inches, for example. And from this you can use it to measure soil nutrients, soil carbon, soil bulk density based upon the volume of the push probe, and use this to measure procedures like wet aggregate stability. This is a shovel we use for measuring dry aggregate stability, and for this you want to measure it on the top 2 inches of the soil, and this is exactly 2 inches. So what you do with this is you push it down a little ways and you cut a spot so it's down to 2 inches. And then you push it and try to keep it flush with the soil down to 2 inches, and you end up with this. And for dry aggregate stability, you want to put it in a large tray like this and avoid breaking up the soil structure as much as possible. And you want to collect like a kilogram or 2 of soil for that procedure. So you want to collect a lot of soil. For methods like wet aggregate stability or soil nutrients, you don't need as much sample, so you can measure quite a bit of soil fertility properties with how much we have collected here. But for dry aggregate stability, you want a large amount of soil. So I would take like 3 shovelfuls if I was going to measure dry aggregate stability of this shovel. And another method that's used to collect cores for saturated hydraulic conductivity, water retention, and bulk density, and is a lot more accurate than using the push probe for determining bulk density, is a Eulen Core. And for a Eulen Core, you use rings like here, and you want to place them into the core with the number up. Like this is core 197. And then you place these spacer rings in here so it doesn't go up onto the sample. And then you slide the spacer rings into it. And then you're going to want to take a sliding hammer, and you want to gently use the sliding hammer and drop it and keep the sample as straight as possible vertical. And just continually drop the sliding hammer till it goes in. pound it in, you take a shovel and you very gently pull it up. This is probably going to fall out. And you don't want that to happen where it falls out. And that's an issue when the soil's dry. You want a core to come out in it. Oh crap. I might need to refill this tomorrow in the garden. So we're about done pounding this in. And then we need to take a shovel and somehow dig underneath this because it's breaking out. So we got to dig below it. And very gently pull this up. And then you want to break off this very carefully. Oh shit. And then you have your core, and then you want to keep the bottom on the core and just leave the top little bit on the core. And then just set it inside a plastic bag very gently. Could you open this for me?
Mm-hmm.
And then you want to keep it upward so it doesn't come off. And you want to keep excess sample in the bag so you can add to it as needed if it falls apart. And you ideally don't want any of it to fall out. Then you have your sample in a plastic bag here. So here's how you collect samples to measure saturated hydraulic conductivity and water retention and bulk density. And this is called the Eulen Core technique. Okay. So here is a Giddings probe. It can be mounted on the back of a truck or back of a tractor. And at first you push this down so it's vertical like this. And then you lower this downward, and then that pushes this firm onto the soil surface. And then you put your probe on here and you place a bolt through here to hold the probe mounted onto here. And there's different adapters for the different size probes that you put on the Giddings probe. So you can have adapters that are from 1 inch in diameter to like 5 inches in diameter. And then you have an adapter that slides onto here, and you put a screw or bolt through there, and then onto the adapter you put your probe of whatever size, and that slides in here, and then you put a bolt through there, and then you use this lever here to push it downward, and then this slides downward into the soil, and this can go approximately 1 meter deep into the soil. Some probes are as much as 2 meters, but not every soil you can push the probe down to 2 meters. And then you can go downward one way and upward the other way. And that will pull it back up out of the soil then. And then you can take the probe off of here and you can take the soil out and you can cut the soil to different lengths. So that's the basics to what a Giddings probe does. And it can be